What if I told you that just days ago, something happened in the depths of space that left even NASA completely stunned? A mysterious signal, unlike anything we've ever seen before, suddenly appeared, and no one knows where it came from or what it means. Some scientists think it could be a new kind of cosmic phenomenon. Others wonder if it's something far more shocking. In this video, we'll break down exactly what NASA discovered, why it has experts scratching their heads, and what this could mean for the future of space exploration, or even life beyond Earth. Stay with me, because the deeper we go, the stranger it gets. You're watching Mysteries and Discoveries, the place where we dive deep into the most fascinating secrets of the universe. If you love space, science, and unraveling the unknown, make sure to hit that subscribe button right now so you don't miss our future explorations. Alright, let's get started. The story begins with a detection. Scientists at NASA, using one of their most advanced radio observatories, noticed a sharp burst of energy coming from deep space. At first, it looked like what astronomers call an FRB, a fast radio burst. FRBs are extremely brief, powerful flashes of radio waves that last just milliseconds but can release more energy than the sun produces in an entire year. But this signal wasn't like any FRB they'd catalogued before. For one thing, it seemed to repeat. Not in a neat, predictable cycle, but sporadically, as if something, or someone, was turning it on and off. Then came the second twist. The frequency of the signal appeared slightly distorted, bending in ways that suggested it had traveled across vast cosmic distances, through magnetic fields and interstellar plasma. Yet even after accounting for all of that, the data didn't quite add up. At NASA's Jet Propulsion Laboratory, one astrophysicist described it as a puzzle piece that doesn't fit any known puzzle. Another scientist at Harvard said, "We've never seen a signature quite like this before. It's either something entirely new in astrophysics, or it's a sign of something we simply don't understand yet." Let's pause here, because if you followed the history of space discoveries, you know that strange signals are not new. Back in 1967, when Jocelyn Bell Burnell first detected the rhythmic pulses of a radio source, it was so precise that some astronomers half-jokingly labeled it LGM-1, short for Little Green Men 1. Of course, it turned out to be the first known pulsar, a rapidly spinning neutron star. What once looked like a message was really nature itself, speaking in a language we hadn't yet learned. But that's what makes this new detection so fascinating. Could it be another natural phenomenon waiting to be classified? Or is it something truly unprecedented? To understand the weight of this discovery, let's dig into what NASA actually saw. The signal didn't arrive as a clean ping. It came through in bursts, almost like echoes bouncing in the dark. The timing was irregular, and yet not random. Certain bursts clustered together, then there would be silence, followed by a longer, drawn-out emission. Some compared it to cosmic Morse code, but without a key to decipher it. Advanced instruments filtered the raw data, and that's when the shock really hit. The energy source behind these emissions appeared to be billions of light-years away. Imagine that, light that began its journey before Earth even had complex life forms, now reaching our antennas in 2025. If that doesn't give you chills, I don't know what will. But here's where the mystery deepens. The usual suspects, magnetars, quasars, black holes feeding on gas, don't fit perfectly. Magnetars, for example, are known to emit powerful bursts, and some are thought to be responsible for certain FRBs. But this signal had an unusual structure in its spectrum, suggesting something more complicated at play. One astrophysicist working with NASA was quoted as saying, "If this is a magnetar, it's behaving in ways we've never seen before." Others speculated that perhaps we were witnessing the signature of an exotic object, maybe a neutron star colliding with an unknown companion, or even the remnants of a primordial black hole. And yet, the whispers of speculation went further. Could this be, some asked quietly, an artificial signal? Now, let's be clear, NASA is extremely cautious when it comes to such claims. Officially, they treat all unexplained signals as natural until proven otherwise. History has taught scientists that the extraordinary almost always has an explanation grounded in physics. Still, the mere possibility keeps the discussion alive. At SETI, the search for extraterrestrial intelligence, researchers immediately flagged the data for deeper analysis. SETI scientists are experts at filtering out human-made interference, like satellites or radio chatter from Earth. After running checks, they ruled out the possibility that the signal was just a glitch or local interference. This thing was real, coming from out there, not from us. That's when the headline started circulating, "NASA detects unexplained signal." And just like that, the world's imagination lit up. Were we finally on the brink of confirming intelligent life beyond Earth? Before you jump to conclusions, let's weigh the science. If this is natural, what could it be? If it's not, what are we truly looking at? And most importantly, what does NASA actually believe? To answer that, we need to step back and explore the history of strange cosmic signals. Because this isn't the first time something unexplainable has reached our antennas. Take the WOW signal of 1977. Astronomer Jerry Ehrman spotted a strong, narrowband radio signal while working on the Big Ear radio telescope in Ohio. It lasted 72 seconds, and to this day, no one has identified its source. Ehrman famously circled it on the printout and wrote "WOW" in the margin. Decades later, we still don't know whether it was a natural emission or something more. Or consider the mysterious Tabby star, which dimmed in strange, irregular patterns that some speculated might be caused by alien megastructures. In the end, the explanation leaned toward dust clouds and natural variability, but the fact remains, our universe constantly presents us with puzzles that force us to expand our understanding. This latest NASA detection belongs to that same category, an unsolved puzzle, balancing on the line between the known and the unknown. And here's where things get fascinating. If this signal is natural, it could reveal entirely new physics. Imagine discovering a type of star we never knew existed. Or uncovering evidence for exotic objects like boson stars or axion clouds, theoretical entities predicted by particle physics but never observed. If it's artificial, well, then we are standing at the edge of history. An artificial signal would imply technology. And technology implies intelligence. Even the faintest hint of such a discovery would be the most groundbreaking moment in human history. For now, NASA isn't making that leap. They're calling it anomalous, unexplained, but real. Instruments are being recalibrated, observatories around the globe are aiming their dishes at the same patch of sky, and teams are collaborating across continents to figure this out. Think about that for a moment, the entire scientific world, united by curiosity, staring into the cosmos together, asking the same question, what just happened out there? Before we go deeper, let me pause for a second. If you're enjoying this dive into one of the most fascinating cosmic mysteries of our time, make sure you've subscribed to Mysteries and Discoveries. We bring you the latest space and science revelations, explained in detail, with all the wonder and all the facts. And trust me, you won't want to miss what's coming next. Now, let's explore another angle, what this could mean for the search for extraterrestrial intelligence. So, what does this unexplained signal mean for the search for extraterrestrial intelligence? To answer that, we have to understand how carefully scientists approach this question. Contrary to popular belief, NASA isn't quick to cry aliens. In fact, they lean heavily in the opposite direction. The reason is simple: history has taught us that most mysteries, given enough time, eventually reveal themselves as natural phenomena. Take pulsars, for example. When they were first detected, the perfectly timed pulses seemed almost like a beacon, so regular, so structured, that it felt artificial. Jocelyn Bell Burnell herself admitted that the thought of an intelligent source crossed her mind. But deeper study revealed that pulsars are simply neutron stars spinning at incredible speeds, their magnetic poles sweeping across the cosmos like lighthouses. What once seemed like intelligence turned out to be physics, strange, exotic physics, but physics nonetheless. That's why today, when NASA encounters a signal they can't explain, their first instinct is caution. They run exhaustive tests to rule out interference. Could the signal have come from one of our own satellites? Could it be a reflection of Earth's own radio chatter bouncing around the atmosphere? Could a passing airplane have crossed a telescope's field of view at just the wrong moment? To eliminate these possibilities, scientists don't just rely on one observatory. They reach out to others, in Canada, in Australia, in China, in Europe. If multiple observatories detect the same signal from the same region of sky, at different times and using different instruments, then it's far less likely to be local interference. That's exactly what's happening now. This latest NASA discovery has triggered a global collaboration, with teams scanning the same coordinates, trying to replicate the detection. But replication hasn't been easy. The signal is sporadic. Sometimes it appears strong, almost screaming across the cosmic background. Other times, it vanishes for hours, even days. That's what makes it so maddening. A steady, repeating signal would be easier to analyze. A fleeting, unpredictable one forces scientists to wait, often in vain, hoping the cosmos decides to whisper again. Now, let's zoom out. What kinds of cosmic phenomena could produce something like this? Scientists have a list of suspects, and each one is fascinating. First, there are magnetars, neutron stars with magnetic fields so intense that they could strip the credit cards right out of your wallet from halfway across the solar system. These monstrous objects occasionally flare, releasing bursts of X-rays and gamma rays. Some magnetars have been linked to fast radio bursts. But the structure of this signal doesn't perfectly match known magnetar emissions. Then there are quasars, the blazing hearts of distant galaxies powered by supermassive black holes. Quasars can outshine entire galaxies, releasing jets of radiation across the universe. But quasars tend to emit continuously, not in sharp, irregular bursts like the ones detected. Another candidate, binary star systems, where two stars orbit each other in a cosmic dance. As they interact, especially if one is a neutron star or black hole, they can produce strange emissions. But again, the details don't quite fit. This is the beauty of astrophysics, every mystery is a doorway. Even if the explanation turns out to be natural, it almost always expands our understanding of the universe. Let's pause here for a second, because the stakes go beyond science alone. Discoveries like this capture the public imagination in ways that few other things can. Think about it, billions of people live their lives largely disconnected from the stars above. Yet when a headline breaks, NASA detects strange signal, suddenly everyone looks upward. Suddenly, people wonder if we're alone, if the universe is more alive than we realize. That sense of wonder is powerful. It drives funding. It inspires new generations of scientists. It makes children point at the night sky and dream of becoming astronauts, engineers, astronomers. So even when NASA says, "We don't know what this is yet," the mystery itself becomes fuel for curiosity, fuel for imagination, fuel for discovery. And that's where your role, as a viewer, comes in. If you're fascinated by these stories, the mysteries of space, the discoveries that push science forward, make sure you're subscribed to Mysteries and Discoveries. That way you'll never miss these deep dives into the universe's greatest secrets. Now, let's dig deeper into how scientists analyze signals like this one. When a strange burst arrives, raw data pours in as squiggly lines, intensity versus frequency over time. Astronomers then apply sophisticated algorithms to clean the data. They remove background noise, account for Earth's rotation, and correct for the distortions caused by interstellar gas and plasma. This process, called dispersion measure analysis, allows them to estimate how far the signal has traveled. The signal in question appears to have journeyed billions of light-years. That's mind-boggling. To put it into perspective, if the source of this signal had sent a message the moment dinosaurs first walked the Earth, it would still just be reaching us now. We're essentially eavesdropping on ancient history, cosmic history that predates us by unimaginable scales. But here's the strange part, the signal looks too structured, too organized, to be pure chaos. Nature is messy, yet this emission carries patterns that hint at order. Not language, not communication, but order. It's like hearing a rhythm in the static. And that rhythm is what has scientists on edge. We've seen this before. In 2007, the first fast radio burst was detected, completely by accident, while reanalyzing old pulsar data. At first, no one believed it. Then more were found. Now, we've catalogued hundreds. Each one adds a new twist. Some repeat. Some don't. Some seem connected to galaxies. Others, we still can't pin down. This new detection might be the most unusual of them all. Not because it's the loudest. Not because it's the farthest. But because it refuses to fit into any neat box. As one NASA scientist said off the record, it's like finding a footprint on a beach where no one should have walked. You don't know if it's an animal, a person, or just erosion, but it doesn't look like it belongs. That analogy captures the mood perfectly. Science thrives on order. Theories, equations, predictions, all designed to make the universe make sense. But sometimes, the cosmos throws a curveball. And when it does, the smartest minds on Earth admit, we don't know. Now, let's address the question everyone asks: what if this is artificial? SETI researchers, though cautious, always keep this possibility in mind. If an advanced civilization were trying to make contact, or even just leaking signals the way we leak television and radio waves into space, this is exactly how we might detect them, as strange bursts of energy that don't match natural expectations. Carl Sagan once said, "The universe is a pretty big place. If it's just us, seems like an awful waste of space." That sentiment drives much of the search for extraterrestrial intelligence. But here's the sobering truth: extraordinary claims require extraordinary evidence. One signal, no matter how weird, isn't enough. To declare something artificial, scientists would need repeatability, consistency, and a signature that screams technology and not just physics. Still, the possibility lingers in the background. When reporters asked a NASA spokesperson if this could be a sign of alien life, they responded cautiously, "We're not ruling anything out, but we have no evidence to make that claim." That balance, between wonder and skepticism, is the heart of science. So where do we go from here? Multiple observatories are now on alert. Dishes in Chile, South Africa, and China's massive FAST telescope are all tuned in. Data is being shared, analyzed, cross-checked. Every new detection, every tiny clue, adds to the puzzle. At the same time, theorists are busy at their chalkboards and computers. Could dark matter interactions produce such signals? Could cosmic strings, hypothetical defects in space-time itself, be responsible? Could we be seeing echoes of events from the dawn of the universe? Each possibility is wild. Each one challenges our understanding. And each one keeps scientists staring at their data late into the night, searching for meaning in the static. And maybe that's the most human part of this story. The signal itself is just energy, ripples in the fabric of the cosmos. But what it represents, the possibility of discovery, the thrill of the unknown, that's what truly stuns NASA. Not just the detection, but the realization that the universe still has secrets it refuses to give up easily. Because if the cosmos can still surprise us like this, then what else is out there, waiting to be found? When we talk about mysterious signals from space, this latest detection isn't happening in a vacuum. NASA and astronomers around the world have been dealing with unexplained cosmic whispers for decades. And each case, whether solved or still hanging in uncertainty, gives us a map of how science wrestles with the unknown. Let's start with one of the most famous examples, the WOW signal of 1977. For 72 unforgettable seconds, the Big Ear radio telescope in Ohio picked up a powerful, narrowband signal. Jerry Ehrman, the astronomer who spotted it, circled it on the printout and scribbled "WOW" in the margin. That raw, honest reaction has immortalized the event. But here's the thing, despite decades of searching the same region of sky, the signal never repeated. We never heard it again. Some scientists suggested it could have been a natural hydrogen emission from a comet. Others argue it remains unexplained. But the WOW signal lives on in legend, a tantalizing hint that maybe, just maybe, someone out there whispered once and then went silent. Now compare that to NASA's present situation. The current signal is stranger, more complex. It isn't a single, one-time burst like the WOW signal. It's erratic but repeating, appearing sporadically over time. That alone makes it harder to dismiss. It's like the universe is giving us a breadcrumb trail, one piece at a time, but never enough to complete the puzzle. Another historical case worth mentioning is the discovery of pulsars in 1967. At first, when Jocelyn Bell Burnell noticed the perfectly regular pulses, the team half-jokingly called it LGM-1, Little Green Men 1. Of course, it turned out to be a natural phenomenon, one of the most exotic ever discovered, a neutron star spinning like a cosmic lighthouse. The discovery revolutionized astrophysics. And here's the lesson: what seemed unexplainable at first didn't just have an explanation, it opened up an entirely new field of research. Could the same be true today? Could this strange NASA signal be pointing us toward a new class of objects, a new kind of star, or a new physical process we don't yet understand? Many scientists believe so. In fact, some are already hypothesizing that this might be linked to cosmic strings, theoretical defects in space-time that could have formed in the early universe. If real, they'd be relics of the Big Bang itself, a discovery so profound it would reshape physics forever. But here's the twist: unlike pulsars, this signal doesn't fit neatly into a repeating pattern. Pulsars were consistent. This is messy, unpredictable, almost teasing. And that's what has everyone scratching their heads. Let's also talk about Perseus A, a galaxy cluster where astronomers picked up eerie sound waves emitted by supermassive black holes. Converted into audible frequencies, it sounds like a deep cosmic hum, resonating through space. While it's not the same as this current detection, it proves something crucial: the universe is filled with strange, almost musical emissions, many of which we still don't fully understand. When NASA announced this latest signal, one physicist remarked, "It's not the first time the universe has surprised us, and it won't be the last. But this one feels different." So why does it feel different? Partly because of timing. In recent years, our detection technology has advanced dramatically. Instruments like the Canadian Hydrogen Intensity Mapping Experiment, CHIME, and China's FAST telescope have opened new windows on fast radio bursts and deep space signals. We're now hearing things we never could before. It's like upgrading from a crackly AM radio to a crystal-clear digital receiver. Suddenly, the universe sounds richer, louder, stranger. And partly, it feels different because this signal has characteristics that resist easy classification. Scientists have databases of known astrophysical phenomena. They run signals against these databases, looking for matches. Usually, patterns emerge. This time, no match. The algorithms shrug. The databases come up empty. That's when scientists look at each other and say the words they love and fear in equal measure: this doesn't fit. Now, let's dive into the scientific debate happening behind closed doors. On one side, you have the skeptics. They argue that we've been fooled before. Remember the mysterious peritons detected in Australia? For years, astronomers thought they'd found a new kind of cosmic signal, only to discover the culprit: microwaves leaking from the observatory's staff kitchen when someone opened the door mid-cycle. A cosmic mystery, reduced to a lunch break. Skeptics say this new NASA signal might eventually turn out to be something equally mundane: an unknown glitch, interference we haven't identified yet, or a new type of natural radio source. On the other side, you have the optimists. They don't necessarily leap to aliens, but they believe this is something genuinely new. Not a glitch, not a microwave oven, but a real cosmic phenomenon. Maybe it's a magnetar behaving in ways we've never seen before. Maybe it's the death cry of a star collapsing into a black hole. Maybe it's an exotic object we haven't even theorized yet. Between the skeptics and optimists lies a wide middle ground: the cautious realists. NASA tends to fall into this category. Their official stance is almost always the same: we don't know yet. And that's the most honest answer. But what about the possibility everyone thinks of: extraterrestrial intelligence? Here's where things get tricky. The moment you say aliens, headlines explode. Public imagination goes wild. But for scientists, it's the last conclusion, the one you only reach after every other explanation fails. Why? Because claiming alien life isn't just a scientific statement, it's a cultural earthquake. It changes everything about how we see ourselves. That kind of claim requires rock-solid, repeatable, undeniable evidence. Still, let's entertain the idea for a moment. If this signal were artificial, what would that mean? It would mean we're not alone. It would mean another civilization, somewhere across the galaxy, has the technology to send bursts powerful enough to reach us across billions of light years. That alone would imply they're far, far more advanced than we are. The distance, the energy, the precision, all of it suggests a civilization that has mastered its environment in ways we can barely imagine. Some researchers even speculate about Dyson spheres, hypothetical megastructures built around stars to capture their energy. If such structures exist, they might produce signals unlike anything natural. But again, speculation is not evidence. Let's ground this in what's actually happening at NASA. Teams are currently analyzing the signal from multiple angles. They're mapping the dispersion, studying the polarization of the waves, and running simulations to test possible sources. They're sharing data with international partners, cross-checking with different instruments. In essence, they're treating this signal like a crime scene, collecting every clue, examining every detail, ruling out every suspect until only the truth remains. And here's something that rarely makes the headlines, even if the final answer is natural: the process itself, the collaboration, the technology, the breakthroughs along the way, pushes science forward. Sometimes, the pursuit of the mystery teaches us more than the solution itself. Now let's step into the future of exploration. What tools and missions could help us solve mysteries like this one? First, radio astronomy is entering a golden age. Projects like the Square Kilometre Array, SKA, currently under construction, will be the largest radio telescope ever built, capable of detecting signals with unprecedented sensitivity. Imagine what it might hear once it's fully operational. Second, space-based observatories. Earth's atmosphere distorts and blocks certain frequencies, which is why space telescopes like Hubble and James Webb have been game changers. Future missions could place dedicated radio observatories in orbit, free from earthly interference, giving us a clearer ear to the cosmos. Third, artificial intelligence. Machine learning algorithms are now being trained to sift through mountains of data, spotting patterns human eyes might miss. In fact, some recent fast radio bursts were first identified by AI. It's possible that the mysteries of the cosmos will be unraveled not just by scientists, but by algorithms that never tire, never blink, never overlook. And finally, international collaboration. Space is too vast, too complex, for any one nation to decode alone. The mystery of this signal is already proving that. American, European, Chinese, Canadian, and Australian observatories are all sharing data, all contributing. In that sense, the signal has already done something profound. It's united humanity, even if just for a moment, in the shared pursuit of knowledge. Now, if you've stayed with me this far, you're exactly the kind of mind we need on this adventure into the unknown. So let me remind you, if you haven't already, hit that subscribe button to join us here at Mysteries and Discoveries. This way, you'll always be part of the conversation when new revelations shake the world of science. To close this section, let's reflect on what makes this moment so powerful. It's not just the signal itself. It's what it represents. For centuries, humanity looked at the night sky and wondered. We built telescopes, radios, satellites, all to catch whispers from the cosmos. And now, one of those whispers has left NASA itself stunned. That tells us something profound. We are still children in a vast universe, still learning to listen, still stumbling upon mysteries we cannot yet explain. And maybe that's the greatest discovery of all, that the universe is not done surprising us. So let's push the thought experiment further. What if this strange signal isn't natural at all? What if, against all odds, NASA has stumbled upon evidence of another civilization? How would the world react? How would humanity process the knowledge that we are no longer alone in the cosmos? This isn't just science fiction. Scientists, philosophers, even governments have debated this scenario for decades. It's called the first contact problem. And the answers aren't as simple as you might think. The first reaction, most likely, would be shock. Imagine waking up to headlines saying, NASA confirms signal from alien civilization. Social media would explode. Stock markets might shake. Religious leaders would issue statements. Politicians would scramble to respond. Suddenly, humanity's place in the universe would shift in an instant. For some, it would be exhilarating. Proof that we're not alone could feel like the greatest discovery in human history. But for others, it could be terrifying. After all, if there's someone else out there, what does that mean for us? Are they friendly? Are they dangerous? Do they even care about us at all? History suggests that when civilizations meet, the outcome is rarely simple. Sometimes it leads to cooperation and exchange. Other times, it leads to conflict. That's why many scientists, including Stephen Hawking, warned against actively broadcasting our existence. If aliens visit us, Hawking once said, the outcome might be similar to when Columbus landed in America, which didn't turn out well for the Native Americans. But here's the key difference: this signal, if artificial, likely comes from so far away that whoever sent it is probably long gone. Remember, we're talking about billions of light years. The civilization that created it might not even exist anymore. We may simply be listening to an echo of their past. Let's consider the religious dimension. Across the world, billions of people look to faith traditions that place humanity at the center of creation. How would those beliefs adapt to the discovery of alien intelligence? Some religious scholars say it would simply expand the scope of creation. God, after all, could create life anywhere. Others worry it could shake foundational beliefs. In 2009, the Vatican astronomer José Gabriel Funes said something remarkable: the existence of extraterrestrial life does not contradict the faith, because we cannot put limits on God's creative freedom. Statements like that show that some religious institutions are already preparing for the possibility. But in other places, the response might be more defensive, even fearful. The idea that we're not unique could be unsettling to those who see humanity as central to the cosmos. Now, what about governments? There's actually a protocol, the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. It was drafted by the International Academy of Astronautics in the 1980s. It outlines steps for verifying any detection, informing governments, and releasing information to the public. But here's the truth: no one really knows how governments would react. Would they be transparent? Would they hide information, worried about panic? Would they try to control the narrative? History shows us that secrecy is tempting. During the Cold War, both the United States and the Soviet Union kept many discoveries classified before releasing them to the public. Some believe the same would happen with aliens, that we might not know right away, or that the information would be filtered. On the other hand, in today's world of instant communication and global networks, keeping such a discovery secret might be impossible. The data is shared across too many observatories, too many scientists. One leak could expose everything. But let's step back from politics and ask the bigger question: what does this mean for humanity's future? If the signal is natural, it pushes science forward. We learn more about the universe, refine our theories, maybe even discover new physics. That alone is exciting. But if the signal is artificial, it means intelligence has arisen elsewhere. And if it happened once, it can happen again. Suddenly, the idea of life beyond Earth isn't just possible, it's proven. That changes how we see ourselves. We're no longer the center of the story. We're part of a cosmic community, even if distant, even if silent. Would that inspire us to explore more boldly, to colonize other planets, to reach further into the stars? Many believe it would. Just as the discovery of new continents on Earth once drove exploration, the discovery of new intelligence might drive us to expand beyond Earth like never before. Mars, Europa, Titan, these places wouldn't just be scientific curiosities anymore. They'd be steps toward joining a larger cosmic conversation. But here's a sobering thought: if civilizations rise and fall, what does that say about us? The signal we're detecting now may come from a society that no longer exists. That should make us pause. Are we destined to burn bright and then vanish, leaving only whispers across the stars? Or can we learn, adapt, and build a future where humanity endures for millions of years? Carl Sagan often reminded us of the pale blue dot, Earth, suspended in a sunbeam, fragile and alone. If we're now hearing from others, even faintly, it's a reminder that survival is not guaranteed. The universe is harsh. Stars die. Planets change. Life is precarious. But it's also resilient. The fact that we're here, listening, is proof of that resilience. Now, let me ask you something directly, because this is where the conversation goes beyond NASA and beyond scientists. White right pointing back hand index. If NASA confirmed tomorrow that this signal was truly artificial, coming from another civilization, how do you think humanity should respond? Should we try to send a reply? Should we stay silent and just observe? Or should we focus on protecting ourselves first? I'd love to hear your thoughts. Drop your answers in the comments below, because in some ways, this question belongs to all of us, not just the scientists. Before we move on, if you're finding this discussion as fascinating as I am, remember to subscribe to Mysteries and Discoveries. That way, you'll always be part of these deep explorations into science and the unknown. Now let's expand into humanity's long-term place in the cosmos. NASA's current signal may remain unexplained for years. But the search will continue, and discoveries will keep piling up. The James Webb Space Telescope is already peering into atmospheres of exoplanets, searching for biosignatures, signs of life like oxygen, methane, or even industrial pollution. Future telescopes will go further, giving us the ability to analyze planets dozens, even hundreds of light-years away. Imagine the day when we point our instruments at a world and detect not just water or oxygen, but chemicals that can only be produced by technology. That would be a second confirmation, a second signal, one not of radio waves, but of industry. And beyond detection, there's contact. Some scientists argue that if we ever receive a clear, undeniable message, we'll need decades just to decide how to respond. What language do we use? What do we say? Do we reveal our location? Do we send mathematics, art, or silence? This debate isn't just theoretical. In 1974, we actually sent a message. The Arecibo telescope in Puerto Rico beamed a binary code toward the Hercules cluster, containing information about humanity, our DNA, our solar system, even a crude image of a human figure. The odds of it being received are slim, but the act itself symbolized our readiness to speak to the stars. And perhaps that's the greatest takeaway from NASA's current discovery. Whether the signal is natural or artificial, whether it's solved tomorrow or in 100 years, it reminds us of something profound: we are listeners in a vast, ancient universe. The cosmos doesn't owe us answers, but it sometimes offers hints. And those hints are enough to drive us forward, to keep us searching, to keep us wondering. Because maybe the real mystery isn't the signal itself. Maybe the real mystery is us, this strange species on a pale blue dot, building machines to catch whispers across billions of light-years, daring to believe we might not be alone. Let's shift our focus now to the question that sits at the heart of this mystery: if strange signals are being detected, where might they actually come from? And if they're not artificial, what do they tell us about the planets and systems around us? When NASA or other observatories detect an unexplained signal, the very next step is usually to cross-check it with known astronomical objects. Could it be coming from a pulsar? From a magnetar? From a galaxy in a starburst phase? But if it doesn't fit, the search moves outward, to planets. And this is where the science gets exciting. Today, we know of more than 5,600 confirmed exoplanets, worlds orbiting stars beyond our solar system. And that number grows almost every week. Some are gas giants like Jupiter, some are rocky like Earth, and many fall into categories we never imagined before: hot Jupiters, mini-Neptunes, super-Earths. But the most intriguing of all are those that sit in the habitable zone, the narrow orbital range around a star where liquid water could exist on the surface. That's not a guarantee of life, of course, but it's a starting point. Earth is in the Sun's habitable zone, and life thrives here. If we find Earth-like planets in similar zones elsewhere, they become prime candidates for study. So when an unusual signal appears, one of the first questions astronomers ask is, does it line up with a star system that has a potentially habitable planet? One famous example is the TRAPPIST-1 system. It's about 40 light-years away and has 7 rocky planets, at least 3 of which are in the habitable zone. If a strange signal ever appeared near TRAPPIST-1, the scientific world would erupt. It would be the perfect target for follow-up observation. This brings us to the idea of biosignatures. Even if a signal isn't a deliberate transmission, planets can reveal their secrets through their atmospheres. When starlight passes through a planet's atmosphere, it carries with it chemical fingerprints: oxygen, carbon dioxide, methane, water vapor. By analyzing these fingerprints, astronomers can detect whether the conditions are right for life. The James Webb Space Telescope, launched in 2021, has already begun this work. It has analyzed exoplanet atmospheres, and while we haven't yet found definitive signs of life, we're inching closer. Imagine the moment when Webb or its successors detect a chemical imbalance that can't be explained by geology alone, something that screams biology. That discovery would run parallel with mysterious signals, reinforcing the idea that we're on the verge of something historic. But let's talk about communication challenges. Suppose this strange signal really is artificial, a deliberate broadcast. That means a civilization chose to send it across unimaginable distances. But why? And how? Radio waves are the easiest method, and that's what SETI has been listening for since the 1960s. The advantage of radio is that it travels far and can carry a lot of information. The downside? It takes time. A message sent from even 100 light-years away would take a century to reach us. If we replied, our response would take another century to get back. That's a 200-year conversation, hardly practical. So maybe advanced civilizations don't use radio at all. Some scientists speculate they might use lasers, or even quantum entanglement, though the latter remains speculative. Others suggest signals might not be communication at all, but side effects of energy use, like the glow of Dyson spheres, massive structures built to capture a star's energy. In that scenario, the signal isn't a hello. It's simply leakage, like the way Earth has been broadcasting TV and radio for decades. For 100 years, our own planet has been sending a bubble of signals into space. To any civilization within that bubble, Earth already looks like a world with technology. So perhaps what we're detecting now is the same thing, another civilization's geostatic, their unintentional footprint across the galaxy. Now, let's take this idea further. Could it be that signals aren't even meant to be read? Think of a lighthouse on a distant shore. Its beam sweeps across the ocean, not for any one ship, but for whoever happens to see it. Some astronomers believe alien civilizations might do the same, sending out simple repeating signals, not messages, but markers: we are here. A cosmic beacon. If that's the case, then NASA's strange detection could be just that, a beacon we've only now stumbled upon. And that raises another possibility: maybe signals like this are everywhere, and we've simply not tuned our instruments correctly until now. By the way, if you've been enjoying this deep dive into the mysteries of space, make sure to subscribe to Mysteries and Discoveries. It really helps support this channel, and it ensures you don't miss the next big exploration into the unknown. Back to the science, we often assume signals must be intentional. But what if they're byproducts of advanced technology we don't yet understand? Think about it: when humans invented radio, we didn't think about the fact that other civilizations might hear our broadcasts. We just did it for ourselves. What if an alien civilization is using energy at such a massive scale that it spills into space as detectable radiation? Physicist Freeman Dyson once suggested that advanced civilizations might build Dyson spheres, gigantic swarms of satellites surrounding their star to harvest energy. Such structures would emit waste heat detectable in the infrared spectrum. If a signal like NASA's has an unusual infrared signature attached, it might be the first evidence of a Dyson-like technology. Alternatively, some have proposed that signals could come from propulsion systems, enormous drives pushing starships across the galaxy. Imagine ships powered by directed energy beams. From Earth, those beams might look like unexplained pulses or bursts. And here's the twist: what if the signal isn't alien at all, but future humans? This is a fringe idea, but some theorists have wondered whether advanced time travel physics could explain certain cosmic anomalies. While this remains speculative, it highlights how signals can push our imagination as much as our science. The reality is, whatever this signal turns out to be, it's teaching us something new. Even if it's not aliens, even if it's just an unusual star or a new cosmic process, it forces us to refine our understanding of the universe. Every mystery solved expands human knowledge, and every mystery unsolved keeps us curious. So as NASA and the global scientific community continue to investigate, one truth remains: signals like this are more than just noise. They are invitations to look deeper, to ask bigger questions, and to imagine possibilities that stretch far beyond Earth. And maybe that's the real gift of these unexplained detections. They remind us that the universe is not silent. It's humming with energy, with light, with whispers across the void. Some of those whispers we can explain. Others remain mysterious. And somewhere in between lies the truth about who, or what, might be out there. What if the strange signal NASA just detected really is the beginning of something bigger? Throughout this video, we've explored the science, the speculation, and the staggering possibilities behind unexplained signals from space. But before we close, let's step back and ask, how do we, as humanity, prepare for the moment when the mystery is finally solved? Because whether it's tomorrow, in a decade, or in 100 years, the odds are high that one day we'll detect something that cannot be explained away by pulsars, quasars, or interference. And when that happens, the world will change forever. For decades, scientists have worked on what's called contact protocols. These are guidelines for how humanity should respond if we confirm an alien signal. Who makes the announcement? Who speaks for Earth? Do we reply, or stay silent? Some experts argue that we should immediately reach out, eager to make contact. Others believe silence is safer, that drawing attention to ourselves in a galaxy we don't yet understand could be dangerous. It's a debate that blends science, philosophy, and even survival instinct. NASA itself doesn't have a first contact office, but international groups like the SETI Post Detection Task Group do exist. Their job is to evaluate any potential signal, confirm its authenticity, and consider the broader implications. Imagine being in that room, the first humans to realize we are not alone. The weight of that discovery would be unlike anything in history. Of course, not every strange signal is alien in origin. We've seen this play out before. Take the famous WOW signal of 1977. Detected by a radio telescope in Ohio, it was a powerful, narrowband signal that lasted 72 seconds. Astronomer Jerry Ehrman circled it on the printout and scribbled "WOW" in the margin, and the name stuck. To this day, no one has fully explained where it came from. Some think it was a natural source, others an accidental Earth-based transmission. But for many, it remains the best candidate for an alien broadcast we've ever received. Then there are the fast radio bursts, mysterious millisecond-long flashes of radio energy first discovered in 2007. They're now believed to come from highly magnetized neutron stars, but for years they baffled astronomers, with some wondering if they were artificial. Each strange detection sharpens our tools, pushes our science forward, and keeps the question alive: is there someone out there? In the modern era, the search has gained a powerful ally: artificial intelligence. AI can scan vast amounts of telescope data far faster than any human team. In 2023, AI reanalyzed archived data and found 8 previously missed signals of interest. None turned out to be proof of aliens, but the discovery showed how much we might be overlooking simply because the data is too massive for us to handle alone. It's entirely possible that the strange signal NASA just reported will be re-examined by AI, revealing patterns or anomalies we haven't seen yet. This marriage of human curiosity and machine analysis may be what finally unlocks the truth. And so we return to the big picture. Whether the signal is natural or artificial, ordinary or extraordinary, it has already served a profound purpose. It has reminded us of something we often forget in our day-to-day lives, that we live in a vast, mysterious universe, filled with phenomena we don't yet understand. If it turns out to be a new kind of star, that discovery enriches our science. If it turns out to be interference, that teaches us humility. But if, just maybe, it turns out to be a sign of intelligence beyond Earth, then we will have crossed one of the greatest thresholds in human history. Either way, the signal has done its job. It has made us look up. It has made us wonder. Before we end, let me ask you something. If tomorrow NASA confirmed without a doubt that a signal came from an intelligent civilization, what do you think humanity's very first step should be? Should we reply? Should we stay quiet? Or should we prepare for something entirely unexpected? Tell me in the comments what you would do. I'll be reading your answers, and I can't wait to see how this community thinks about one of the biggest questions of all time. If you enjoyed today's deep exploration into the unexplained mysteries of space, make sure to subscribe to Mysteries and Discoveries right now. Hit the like button if you learned something new, and share this video with anyone who loves science, the unknown, or just wonders about our place in the universe. The cosmos is full of secrets waiting to be uncovered, and here on this channel, we'll keep digging into the discoveries that make us rethink everything we thought we knew. Thank you for staying with me through this incredible story. Until next time, keep looking up, because the universe is speaking. The only question is, are we ready to listen?